Good afternoon. Let's try once more. Good afternoon. Namaste. Vanakkam. Sastriyakal. Very lack of energy, man. Come on, guys. So this one has to be interactive. It's a hack session. And you guys have to follow through as in step by step as we go along. So how many here, let me just, before we begin, how many of you have tried your hands at web scraping before? Okay. Half, 10, 20% of the crowd, that's good. So this is going to be kind of an introduction, and we'll try and dabble with some advanced things if time permits us to go about. So a little bit about myself. First, Python enthusiast. I run a community called PyDelhi in Delhi besides my day job. I cycle and well, I take care of the data hack platform as a consultant and the backend person. So what exactly is web scraping? Anyone? Parsing is one, yes, and? So parsing is a subset of scraping up there. Yes, so a lot of data is available online, and if we want to analyze that or do some processing over it, we need it in our own custom data structures. We want to pull it down, store it in an array, in a dictionary, wherever, whatever we are comfortable with. So in order to do that, we first of all have to obtain it. That's where web scraping comes in. So one primary question I'm asked is web scraping legal? Well, kind of. It's a gray area. Maybe. I have had notices from companies when once upon a time it so happened that my spider went and caused their servers to go down, and the company's CEO I was working for got an email saying like, you're abusing our servers, we're going to sue you. So you may get into trouble. How do you avoid that? Be gentle on the websites that you're trying to scrape, and just be a good netizen, in short. So, difference between scraper and a spider? Anyone? No. You're just reading the slide. Cheaters. Anyways, so a scraper would be some kind of a small script which would download a web page and extract data from that page. Whereas a spider is something that goes around the web. What do you do when you write a spider? How many people have written a spider going around? 1, 2. So the process is simple. You have to give it some seed URLs, the pages where you start from. Your program goes to that page. From there, you extract all the pages that you would want to visit next. Keep it in a queue or a stack, whatever data structure suits you, and you recursively go on downloading one page, extracting URLs from there, visiting, and adding them back to the stack. Does that make sense? How many people got that? Half. Okay, so I hope the hack session will make more sense going forward. So let's just switch to the most favorite tool people have here, I hope. So let's just see if the internet is working first of all. What am I going to do? Interesting. Okay, so I hope people here are movie fans in the house? Show fans? None. Okay. Sure. Thanks for highlighting it to me. All right. So we are going to be using just 2 libraries for this exercise here. We can debate why this, why not that, if time permits. So requests, how many people are familiar with requests? Okay, so this is the most downloaded package on PyPy, created by Kenneth Rides, and is an alternative. It's just something that you will use to communicate over HTTP because it gives you a simpler interface. And LXML that you see over here is a simple library which will let you parse the HTML and convert it into a data structure that you can traverse. So in order to go ahead with the exercise, one thing we would need to understand is that HTML is a tree structure. Everyone gets that? In the room, it makes sense to everyone. Good. So because it is a tree, we can find out the path of, we can basically find out the path of one node in that tree, right? You can say go to this node, follow it, and reach a particular node. Does that make sense? Okay. So LXML is one library which will let you convert, first of all, read the HTML and convert it into a tree that you can parse and traverse using code. All right. Okay, so the page that we are going to try and scrape first is this one. All right, so it's just a list of 250 top rated movies on IMDb. First step that we have to do is download the URL, right? Yes? It will be shared online. Yes. And so the idea of this session is that it's going to be so simple that you can just follow through. So as we see that the page was downloaded, so we got the as 200. Would be the entire HTML that was downloaded as when you send the request.get. All right. So I'm just covering the basics for once. All right. So this particular line is what will basically create the tree data structure for you. Now comes the only slightly complex part that needs to be explained. Tiny little bit in detail. The thing that you see in as a string over there is called an XPath. How many people here know what an XPath is? Okay, 10% again, somewhere around 10% of the audience. So XPath is the path of the node. I mean, it's a syntax. You can call it. It's almost like a language which will let you describe the path of a node programmatically. So while there are other alternatives which will help you specify the same detail with Python, this on the other hand is very concise if you can just get the hang of it. So for instance, first step is to go and try to explore Alright, so the first step is to go and explore the elements that you want to extract. For instance, assuming that this is the valuable piece of information on this page, what you want to do is to find how to reach this particular node, okay? So as you can you see the screen? Is this visible? All right. So just for this particular example, that particular string is present inside an h1 tag. Okay, so somehow one option we have is to specify every node in the path, okay, how you would follow through. So this is very much like the Unix file system. People comfortable with the Unix file system? So how do you specify the path to your directory? Let's say a project that you're working on, /home, /your username, /the project name, /something, something, something. So one approach would be to just go like /html, /body, /h1, something, something. So follow through the entire path step at a time. That is first option. Second option, as XPath gives you, is to specify any node, I mean query the tree and let you find the node that you're looking for. So, and one of the tools that will be of assistance in this process is the console itself. So if you're trying out XPaths, this is a place where that is quite possible. Is this visible? All right, let's say, since we're talking about this h1 tag, what we can do is simply come here and say // which says any node which is an h1 in the tree. Surprisingly, this particular web page has only one h1 tag. What you can do is say text node inside the h1 node. Whereas if you add a // it means a text node anywhere inside the h1 node. Does the / and // make sense? If you say /, you're specifying the absolute path, whereas if you specify // it means anywhere in the subnode of the node that you're querying. Okay, so this makes sense to people? Okay. So what we're going to try to do is, well, this is quite simple, and so let's say if we want to find the name of this, names of all the movies here, how would we go about doing that? And now you have to participate because it's a hack session. So all right, anyone take a guess? Yep. Title column is something we can use. What else? Anchor tag, right. All right. So the data is present inside title column and then inside the anchor tag, right. So the XPath that we come up with has to use those two things. All right. Frankly, I had already written something of this kind. If I want the text, I would have to say something of something. So why did this not work? Any idea? No idea? All right. So the data is present. Okay, it did, frankly. So this gives you a list of all the text elements that were present in there. Clear to everyone? You have to respond to that. Yes, good. So, but this is quite simple, right? And if I had to scrape data only from one page, I wouldn't bother with writing a program to do that. Do you know why? Because something like Sublime is very much more helpful in this process. I can just copy the contents on the web page itself and paste it here. and I get almost everything in a format that I can analyze. Cool? But the power of programming would come when I have to do something repeatedly, right? That's when we write code. When the work that I have to do is boring. So let's try something slightly more complicated. So let's say that we have to, let's say we have to follow through and fetch the information that's not present on the main listing page. All right. So one thing we could pick up is, let's say, the director of the movie. So how would we go about doing this? Steps, anyone? Right. So first step would be, from the listing page, we need to extract all the URLs that we would have to visit later. Right. So let's do that as the first step. All right. So we already have the anchor tag here, and if we want to find out an attribute instead of the text element, XPath gives you a neat little utility, which is something like okay, this is not a function. Does this make sense? So for anything that is an attribute of the tag, you can use the @ symbol and get that out of it. So as you can see, all of these are relative URLs, right? Wrong. So what would we have to do? Right. So we will have to. These URLs are relative to the host, to the main domain of the website that you're trying to scrape. So we'll have to append imdb.com after it in order for it to become a URL that we can use. All right. So let's save it in a variable. And next, what can we do? Let's just say, for the time being, okay, we're hitting one URL. We got something. Let's see if this URL actually takes it to the page that we're trying to get to. It does. And now it's the same cycle. So somebody would like to prompt what I have to type here? Anyone? Go ahead. Right. What? Great. Then what do we have to do? Next step is? E-tree. R.text. Right. Okay. All right. So we are able to get the thing here. Next, what we need to do now is so for the time being, the tree object is the tree object in the memory of my notebook is referring to this particular page. I hope this one, right? So what we can do is we can try out the XPath for this element. And so how do we go about doing here? Any guesses how we would go about doing it? It's visible, right? What we want to extract is this particular string over here. Go on. Try it out. Anything? Item prop. Okay. I bet the item prop thing would not be unique to this particular row, right? So one thing that is unique is, yes, spans item prop director, right? So what we can do is find out the span element first, right? Let's go do that. Now we have to compare it to an attribute of the item prop is director. So right. Successful? Cool. So, but this is one unit of the problem. What we rather have to do is use the same thing in here. Yes? And probably with some more values. So, to recap what we've done, the steps are quite simple. What you need is one page where you go, from where you start scraping the data, right? You visit that page, extract all the URLs that you have to scrape further, add all of that to a queue, list, stack, howsoever you want to go about it, right? It would be a queue if you want to do a breadth first search. It would be a stack if you want to do a depth first search. And traversal of the graph that is the website that you're trying to scrape. Same thing, and then you go on popping one element from there and downloading, applying the XPaths to them, extracting the information and iterating over that until the queue that you have is empty. So, well, we can try and clean this information a little. But you get the picture. And if we remove the break from here, we can just let it run and dump everything that we scraped. Based on how fast your internet is, this script will go on iteratively fetching information from the page. So the thing is, what next? Though this is good for a demo, but requests library is blocking in nature. So who here knows what blocking calls are? Huh? Single threaded and queued, and what it does is that it would primarily halt once you fire one request. It will just go and halt until it receives the next response. So no matter how many resources you deploy, but if you're making blocking network calls, your program will not scale. This was a problem I faced in one of my day jobs, and the way to solve that was to use asynchronous programming frameworks. Well, back in 2014, async IO was not available, so I did it with Twisted. What that would do is, how many are familiar with asynchronous programming frameworks? Async IOs and stuff. You've done async programming? Great. So, for the others, what it would do is your network, the function that is running your network call will go to the background, and next iteration, next instance would be called. As soon as you make the network call, the program relinquishes the control of the processor so that other instances of the function can come and execute. Does that make sense? So what happens as a result is that you may have 100 concurrent requests on the website that you're trying to scrape, and going forward, the throughput of your program increases because the processor is not waiting for network IO. Does that make sense? Okay. So for scaling, you have to, if you're developing scraping applications based on scraping, and you want to scale them, blocking network calls is not the way to go. We have some time left for questions, if there are any. Yes. Yes, the script was hitting IMDb site.
So the rating of the IMDb site would be increased because of this our scraping?
Not quite by much, because I'm pretty sure that any respectable website on the web would try to remove all the bots hitting their websites from the data, unless they want to inflate their records.
Okay.
No, this is the basic way, this is the basic method that you would take. For anything, this would work. However, it's a cat and mouse game, and you have to be ingenious, you have to come up with ingenious ways to scrape websites that are trying to be difficult to scrape, hard to get.
So we have a scrapping problem. Actually, the structure of the site keeps changing every week and intermittently. And when it gets changed, we have to recode again. The team is getting engaged to recode again. Is there any solution around that once we do something? Although it does, it is irrespective of changing the structure, it will keep scrapping the data?
So the scraper way of extracting information will not be intelligent. To mitigate the problem, a solution that I had come up with was step number 1. The XPath thing had helped me take the logic and the data separate. So all the XPaths were stored in a database, and what we used to do was calculate the score of how successful a particular XPath is. Let's say I am trying to scrape 100 pages of similar kind from a website, and the XPath worked for all of them one day. So I had a dashboard which used to give me the information of how successful it was in the last run. If there was a failure, there was a pop, and so the method to solve that was to just go and correct the XPath instead of rewriting the whole code base.
Okay. Any solution around getting if you have the data, getting a solution around that scrapping?
So there are some projects which are trying to do something on the same lines. Projects by Scraping Hub themselves, the people who have created ScrapeEye. However, the last time I checked, it wasn't very successful, because you have to give it enough learning data in order to go and do that. With 100 pages, that's not quite enough. Right.
Into the URL, the page.
Right.
When you start scraping it, you have to enter the parameter into the page, and then the page navigates to a particular page and extract the data from that page, go back and enter the other parameter from the spreadsheet, and keep on doing this as long as your spreadsheet has some data.
Right.
How do we go about doing this?
So the spreadsheets can, so there are libraries which can read things from the spreadsheet. That's not very difficult. And as far as URLs are concerned, creating those URLs, as you say, is just a matter of string concatenation.
For example, let us say we have name data present in the spreadsheet. You keep on reading one name, take that name,
Right.
enter that name in the URL,
Right.
and press the enter and get the data out of it. And
So
keep
let's
on
say
navigating.
what you're trying to do is search Google with
Similar.
So depending on how difficult the website is trying to be to scrape. If it is simple, it's just like whatever the URL of the website is, question mark and get parameters. In the get parameter, which is perhaps q is equal to something, you'll always be, I don't know, I can just demonstrate it in some quick thing. We've got 4 minutes to go. Do you have questions, or should I think we can take this offline in a more personal session. Yes. If there is a video, so if the video is available as an HTTP resource, anything that is available as an HTTP resource can easily be downloaded. You get the URL, you say request.get.
I tried scraping Yelp and big websites like Foursquare.
Right.
Every time I get timed out.
Right.
Even though I give little bit of random wait and proceed,
Right.
I get timed out. And the worst part is the whole URL is just getting forbidden.
Right.
Even though I worked in under the proxy. So every time I hit there, my proxy changes, IP address changes. Even then I get forbidden.
Yes. So
because of this, I could not automate my process.
So one of the most basic ways to prohibit people from scraping your data is to see how frequent your hits are, and are they are the requests behaving like a human? If it is monotonous and you are just going on hitting every single URL, that's more like a machine. So well, data scientists in the room would know how to flag that and block the requests. So one way in which I solved a similar problem was so there was one particular website from where I had to scrape 1 lakh URLs every day repeatedly, e-commerce website, and they had a rule which said one request per URL per second was their limit. If you go beyond that, HTTP 429, you're not able to scrape for another 6 or 7 hours. The way to solve that was to launch 100 instances on the web, so that I had unique IPs, and then the requests were delimited by one request wait for a second, fire another one. So brute forcing my way through. So there are a couple of ways to solve a problem, right? You either invent a solution or you throw money at the problem until it disappears. I can have a lag time. So yes, something of that kind. So you have to anyways wait for some interval before you make the next request.
So
yes.
One more question. So
Yes.
what if you don't know your sources? I mean, if you are doing some random search and you have, for example, a review of a movie, right?
A review of?
A movie. For
Okay.
example, Inception movie, I have to read the reviews of from many sources.
Right.
Right. Then you cannot go and get the XPath from each movie site. I mean, the review site, and do it. So any solution for that? I mean, for example, this is just one of the example, but that the sites could be various, right? I mean, different.
So if one approach to solve that problem would be to download. I had made one similar solution was to search a particular search engine. I mean, hit a search engine with your query, and follow through on all the research results, because they have been scraping the data for you. So use their data set. Could be one way.
You can follow it, but then again, you need some text from it, right?
So yes, and the problem with that is that a lot of noise would come. So what you would do is get all the textual data from that platform. What you could do. So this is some particular page. This kind of a query would dump all the text that is there between except removing all the HTML tags, whatever text is there. This would make that appear on your screen. If you do something like this, you will get all the text data, but there would be a lot of noise. I'm pretty sure.
Yeah, basically the problem is the noise. Those advertisements are coming, and then there are the frames which you are not interested. You are interested only in the article, and
so a statistical model to find where the data is one approach that can be made. So I'm running out of time.
Sure. Thank you.
Thank you. I think we can take it off stage. Thank you.